Did you do it? It's December 1st, 2018. And I want to find out if they're messing with our MOHO. You'll see. This article is titled Project MOHO, and it's commemorating the accomplishments of Project MOHO, 1961 to 2011. Project MOHO represented the Earth Sciences answer to the space program. It was an attempt to retrieve a sample of the Earth's mantle by drilling a hole through the Earth's crust to the Mohorovičić discontinuity, or MOHO. I think they're messing with a MOHO, folks, which lies between the two layers. Okay. The National Academy of Sciences undertook this extremely ambitious project for its scientific potential. What began as an almost unfathomable idea grew into a popular project in which the Academy nurtured the concept and sponsored the feasibility phase. In April 1961, the project succeeded in drilling farther into the Earth's crust than ever before. To tell the story of Project MOHO and celebrate the 50th anniversary of its achievements, we present a unique collection of photographs, video, original narratives, and historical documents. Project MOHO was an attempt to retrieve a sample from the Earth's mantle by drilling a hole through the Earth's crust to the Mohorovičić discontinuity, or MOHO. Alright, there it is, 10 to 12 kilometers below the surface, 6 to 7 miles. Wonder where we heard that before. A lot. Okay. The project was suggested in March 19... I've got my mouse set on... I reset my mouse so it wasn't so sensitive, and it's just still screwing with me. So it's going to be a little jumpy every now and then. The project was suggested in March 1957 by Walter Munk, NAS member, National Academy of Science member, 1956, and member of the National Science Foundation Earth Science Panel. The project's objectives were outlined in a proposal of December 1957 by American Miscellaneous Society AMSOC member Harry Hess, and he joined the Academy in 57. Okay. Damn it. Okay. Project MOHO represented, as one historian has described in it, the Earth Sciences answer. Well, I read that already. The ambition of exploration, there's age, makeup. Okay. If successful, this highly ambitious exploration of the intraterrestrial frontier would provide invaluable information on Earth's age, makeup, and internal processes. In addition, evidence drawn from the MOHO could be brought to bear on the question of continental drift, which at the time was still controversial. The Mohorovičić discontinuity, named for Andrej Mohorovičić, a Croatian geologist, who first proposed its existence, marks the boundary between the Earth's crust and mantle. The plan was to drill to the MOHO through the seafloor at those points where the Earth's crust is the thinnest. Well, who came from that region? Croatia. Oh, that guy. I love him. Attempting such an effort on land would have been impracticable, since the drilling equipment would not have withstood the depths and temperatures involved. Ocean drilling offered a further advantage in that undersea samples, unaffected by atmosphere and surface impacts, would provide better evidence of the long-term geological activity than would samples drawn from the land. Now here's a diagram off that webpage, and I'm going to zoom in on it a little bit. It's kind of hard to see. Let's see what we got here. Alright. Now, my cursor is not going to be in my video on the same places as on my screen, but off to the left you'll see kilometers. Go down to 10 miles and go straight over, and you'll see that the deepest oil well was 25,300 feet, somewhere in that area. Okay, and the granitic material below is harder, denser material. Okay, and then over here they're going to show you the MOHO. I don't know if they say 32,000 feet or whatever. They're trying to penetrate just into the mantle, which is about as deep as they can go. I'm sorry, yeah, into the top of the upper mantle. So let's get rid of that. Since we're visual creatures, I want to take you to this one here. It's a little bit better. Now, the test holes they drilled was to 18,000 feet. The MOHO was at 32,000 feet. 33,000 is 10 kilometers. Okay. Anyway, here's a description, a little image you can see in screenshot or whatever. I'm going to give you the link to that. And there's 32,000 feet. is 9.75 kilometers. So 9.75 kilometers. Alright, I'm back to this again. I showed you this before. We're talking about the transition zone. Now what I'm going to suggest here is just kind of like a hypothesis. Alright, now they're trying to drill into this upper mantle, the top of it's all they're going to get. Now, that's denser material than the crust itself. And below the transition zone is it's hotter and it's I don't want to call it necessarily liquid. The closer you get to the transition zone, the more solidified it does get. But the transition zone is supposedly it's got a lot of hydrogen in there and oxygen, the makeups for water. So here's the deal. Now, if there's ever going to be a polar reversal, this is where I speculate it's going to become mechanically decoupled from the upper mantle, or it may, or it's plausible. Okay. Now, the upper mantle is more dense than the crust, but the boundary between the crust and the upper mantle is weak, but not as weak as this transition zone. So most of the mechanically decoupling is going to take place at the transition zone, and you can't rule everything that happens to the upper mantle is going to happen to the crust. So let's go on. I'll give you that link there. Huh, what's that? I don't know what the hell that got there. Okay. Now back to the article. This is the initial first team, the members of the American Miscellaneous Society. Boy, that was messed up. It's no longer in existence. They abolished themselves in the late 60s. Okay, the American Miscellaneous Society. Walter Monk suggested that they should consider what project, regardless of cost, would do the most to open up new avenues of thought and research. He thought that sampling the Earth's mantle would be the most significant. The American Miscellaneous Society, which suggested drilling to the mantle, was an informal group of scientists formed in 1952 by the Office of Naval Research geophysicists Gordon Lill and Carl Alexis. Lill and Alexis came up with the idea for AMSOC when they found themselves handling research proposals that fit into no existing scientific categories. Out of that precarious miscellany, AMSOC emerged as a forum for scientific speculation. At an AMSOC breakfast meeting, Walter Monk, a Scripps Institution of Oceanography geophysicist, proposed his idea for sampling the Earth's mantle. The Society endorsed this idea, and by September 1957, where'd it go? Members Roger Revelle and Tom Gaskell had persuaded the International Union of Geodesy and Geophysics to adopt a resolution that urged the nations of the world to drill to the MOHO discontinuity. In early 1958, the National Science Foundation, there's them again, agreed to provide $15,000 in initial funds for the project. The National Academy of Sciences became the sponsor of the Project MOHO when in April 1958, with Academy assent, the AMSOC Committee of 14 was made a full-fledged unit of the Division of the Earth. Okay, in 1958, a meeting of the geophysicists was held in the Great Hall of the National Academy of Sciences building to discuss the AMSOC plan. Transcripts from that meeting show three main points of opposition. The first argument was that the sample taken from one hole could not be expected to represent the entire mantle, and that 10 or even 100 holes were needed. They're going to be drilling this earth like Swiss cheese here. To which Harry Hess, then chairman of the Research Council's Earth Sciences Division, answered, "Perhaps it is true. We won't find out much about the Earth's interior from one hole, but if there is not a first hole, there cannot be a second, or a 10th, or a 100th hole. We must make a beginning." After ocean-going trials off of La Jolla, California, Phase 1 began in earnest with a set of drilling experiments near Guadalupe, Mexico, in March and April of 1961. Okay. The research vessel Horizon laid down the buoys to orient the CUS-1's positioning system, after which CUS-1 took up station. 5 holes, one of which extended to 601 feet beneath the seafloor, were drilled under 11,700 feet of water. Now, La Jolla, California is right there where the balloon is, and I typed in Guadalupe, Mexico. They're showing it over there. But they also mentioned that it's off the Pacific coast of Mexico. So there's a lot of contradictions going on in my reading here, and it's not me. I didn't write this stuff. Now I'm not going to talk about any of this, but in this link I'm going to give you, there's a lot of information. It's excellent to read, and I believe most of it. Okay. All right. But down at the bottom of this is real cute. Let me tell you. Let me click on this, see how it works out. I'm just going to give you a small example of, maybe they're just playing. They think it's funny, or they're making songs out of it. Now it's called the MOHO song, and I don't know how well this is going to turn out. But here you go. Check this out.
Dig under the sea. We're gonna dig under the sea. We're gonna dig under the sea. Down under the sea. Go, row the chick. Go, row the chick. Go, row the chick. Down under the sea. We're gonna go down through the sediment floor. We're gonna go down through the sediment floor. We're gonna go down through the sediment floor. Down under the sea. Go, row the chick. Go, row the chick. Go, row the chick. Down under the sea. We're gonna drill through the basalt. We're gonna drill through the basalt. We're gonna drill through the basalt. Down under the sea. Ho, row the chick. Ho, row the chick. Ho, row the chick. Down under the sea. Hey, what does this song mean, Mike? What's a MOHO chick?
You mean who's a MOHO? He was a geologist from Croatia and an early seismologist.
Well, what did he do?
He was the first scientist to postulate that there was a boundary between the Earth's crust and the underlying mantle. It was known as the MOHO discontinuity in his honor, but most people just call it the MOHO.
Well, what's all this about digging in the ocean?
They're talking about Project MOHO.
Were they drilling moholes?
No, it was a National Research Council project. It was funded by the National Science Foundation to drill down to the MOHO.
But why were they drilling the ocean?
Because that's where the Earth's crust is the thinnest.
Did they make it to the MOHO?
No, it turned out to be too costly, but they did have a big success.
What was that?
They got to the second layer of the Earth's crust for the first time and learned that it was made of basalt.
Wow. And it inspired this catchy tune.
Right.
Should we do the fourth verse?
Go right ahead.
We're gonna go right through the mantle. We're gonna go right through the mantle. We're gonna go right through the mantle. Down under the sea. Sing it with me. Ho, row a chick. Ho, row a chick. Ho, row a chick. Down under the sea. Down under the sea. Down under the sea.
Oh my God. Okay, folks. I'm going to end this video on that one there. But I really didn't think it was going to be a three-part deal. But I'm going to give you all the links I just showed you. And we're going to start out at the Woods Hole Oceanographic Institution with part 3. All right, did you do it?